In this lesson, we introduce you to the logarithm. What is a logarithm? A logarithm is simply another way of writing an exponent. That's all it is. Same thing. A logarithm, again, says right here, or a log is another way of writing an exponent. Here's how you change forms. This is called logarithmic form. Log, like what's on your calculator. The log, and this is a subscript. This number is normally written down here below, and it looks here like it's written next to, but it's a subscript. Log base b of a is equal to x. That's how we read that. Log base b of a is equal to x. Written in exponential form, because again, this is just another way of writing an exponent. This is rewritten as b raised to the x power is equal to a. Very important that we know how to change from one form to the other form. This is called the base of the logarithm. The base of the logarithm and the base of the exponent, same value. The number on the other side would be your exponent, and then whatever what I call the argument of your logarithm is what's on the other side of your exponent. Let's convert these from log to exponential form. Let's zoom in. This one says log base 3 of 9 is equal to 2 is how you read it. The base of your logarithm will also be the base of the exponent. The exponent's always on the other side, so you'll do 3 raised to the second power is equal to this number, 9. That's how you rewrite it. Let's do another one. 6 raised to the third power is equal to the argument, which is 216. That's rewriting. Here, 7 is the base of the logarithm raised to the 0 power is equal to 1. That's exponential form. 2 raised to the fourth power is equal to 16 is how you rewrite that. 4, the base of the logarithm raised to this power, that's the exponent on the other side, is equal to the argument, or 1/16. Number 6, 9 to the 3/2 power is equal to 27. Now's a great time to review on what does that 9 to the 3/2 mean. And you can check this. Second root of 9 to the third would be 3 to the third power, and that does equal 27. Now let's go the other direction. Let's write each equation in logarithmic form. 14 squared equals 196. That would be a log. The base of your exponent goes down here. Log base 14 of 196 is equal to the exponent. And you remember 14 to the second is 196. Log base 3 of the number on the other side is equal to the exponent. 3 to the fourth is 81. Log base 12, same as the base of the exponent, of the number on the other side is equal to the exponent. 12 to the first equals 12, you can check. Log base 36 of the value on the other side of the equal sign is equal to the exponent, or 36 to the 1/2 power is 6, going back and forth. Log base 2 of 1/8 is equal to the exponent, -3, and one more. Log base 8 of 16. 8 to what power 16 would be 4/3. Now a special type of logarithm, and this is actually the log that's on your calculator, the log button. It's called a common log. A logarithm with a base of 10 is called a common log and can be written without the base. So log base 10 of x is the same thing as log of x. If there's no number down here, it's understood to be a 10. So now calculating logarithms says use your knowledge of exponents to evaluate the following. So log base 7 of 49 now. If you think about the other form, what you're saying here, you can rewrite it if you need to until you get comfortable. 7 raised to x is 49. So therefore 7 to what power would be 49? So log base 7 of 49 would be 2, because 7 to the second is 49. Log base 3 of 27, if you need to rewrite it, would be 3 to the x power equals 27. So you're asking yourself 3 to what power is 27, which would be 3. Log base 3 of 27 would be 3. Number 15. There's no number there. It's understood to be 10. This is a common log. 10 to what power is 100? X would have to be 2 because 10 squared is 100. 10 times 10. Number 16, log base 12 of 1. You can put the x if you need to. 12 rewritten is 12 to the x is 1. 12 to what power is 1? Anything raised to the 0 power is 1. Number 17. Log base 2 of 64 is saying 2 to what power is 64? 2, 4, 8, 16, 32, 64. That'd be 2 to the 6th power is 64. Log base 3 of 243 is saying 3 to what power is 243? That'd be 3 to the 5th power. Number 19. This one's a little bit trickier. 9 to what power is 1 over 81? Now, 9 to the 2nd power is 1. It would be 81. But we need a 1 over 81. Well, what happens when you raise it to a negative power? That means you'd have to bring it to the bottom, and that would become positive. So therefore, 9 to the negative 2 power would be 1 over 81. Now, this one's tricky. 64 to what power is 4? Now, I know 4 times 4 times 4 is 64, but how do I go from 64 back to 4? If 4 to the 3rd is 64, then that means that the cube root of 64 would be 4. So therefore, what power would that be? 64 to what power? A cube root is a 1/3 power. So think about vice versa. If 4 to the 3rd is 64, then 64 to the 1/3 would be 4. So therefore, 64 to the 1/3 power would be 4. Next section. You have a very important formula. It's called the change of base formula. Some logarithms are not as easy to evaluate as the ones that we just had. So therefore, these other ones will require what's called the change of base formula. And here's what the change of base formula says. It says if you have the log base b of a, and you want to change it to another base like 10, a common log, because that's what's on your calculator, you can do so by following the following steps. You can take the log of a, and notice now that my log is a base 10. You can change it like this. Find the log of a, and you divide it by the log of the base. You can actually use this formula to change it to any base you wanted to. If you want to change it to a base 7, just put a 7 there. If you want to change them for some reason to a base 8, you can put an 8 there. But you can change it to any base that you would want to by doing the log of the argument divided by the log of the base. So here it says evaluate each log using the change of base formula. It says choose base 10 because there is a calculator button for it. Again, the LOG button on your calculator, that's what it's for. So to type this in our calculator, we're going to do the log of 64 divided by the log of the base. We type that straight into our calculator. And you've got to be careful as you type it in because make sure that you close these parentheses right here before you hit divided by. But you should get log of 64 divided by log of 16. You should get a 1.5. Make sure that you can type this in your calculator and make sure that that is what you get. Log of 32 divided by, log of base 8 of 32. We're going to type in as the log of the argument divided by the log of the base. And again, I changed them to base 10s. Notice that the 10s are down here because that's what your calculator can do, is log base 10. So when you type that in, 8 to what power is equal to 32 is actually what you're finding. You should get 1.6 repeating. Number 23. Log base 2 of 54, you type in as the log base 10 of 54 divided by log base 10 of 2. Type that into your calculator, and you get 5.7549. Now, what did you just find? The original problem was log base 2 of 54. 2 to what power is equal to 54? If you do 2 to the 5th power, that's 32. 2 to the 6th power is 64. That's too high. 2 to this power would be 54. Now, this one would be silly to do it this way, but I'm going to do it anyway. Log base 10 of 294 is the log of 294 divided by the log of 10. On bottom, this log of 10, if you type it in, you would get that the log of 10 is equal to 1. So really, we didn't need that bottom. Well, the reason why is because base 10, Log base 10 of 294 is the same thing as log of 294. You don't have to change bases because your calculator can do base 10s. When you type this in, you should get 2.4683. So 10 to that power is equal to 294. Number 25, and these are irrational values. These logs that aren't perfect logs like that is going to be an irrational value there. You're saying log base 4 of 136 would be the log of 136 divided by the log of 4. When you type that in, you should get 3.5437. And each and every one of these you need to be typing in to make sure that you're getting the same answers. And this one we already know the answer, hopefully. 6 to what power is 1 over 36, but you could type it in as the log of 1 over 36 divided by the log of 6, which is, again, uglier than actually working it out for yourself. But when you type that in, you should get negative 2. Now, why? Because 6 to the negative 2, bring it to the bottom, is equal to 1 over 36.